in last session we were discussed about the relationship between the zeros and the coefficients of the cubic polynomial. According to last 2 or 3 sessions, let's prepare some notes. Please keep in mind. First is for linear polynomial. P of x is equals to ax plus b, where coefficient of a does not equals to 0 and ab belongs to R. P of x is equals to ax plus b represent a linear polynomial. Therefore, keep in mind 0 of linear polynomial is equals to minus b upon a is equals to, where b is equals to constant term minus as it is, b is the constant term upon a. A is equals to coefficient of x, coefficient of x. It is a relationship between the 0 and the coefficient of linear polynomial, as we learned previous lectures. The second one. Second is for quadratic polynomial. P of x is equals to ax square plus bx plus c, where again some condition a does not equals to 0, a, b, c belongs to R. Ax square plus bx plus c represent the quadratic polynomial. Again we know that there are two relationships. First is the sum of 0 and second is the product of 0. Alpha and beta are the zeros of quadratic polynomial. Alpha plus beta, sum of zeros is equals to minus b upon a is equals to minus, instead of b is equals to coefficient of x upon, instead of a is equals to coefficient of x square. Keep in mind the first relationship. Now second, alpha into beta. Alpha into beta is equals to product of 0. Alpha into beta, alpha and beta are the zeros of quadratic polynomials is equals to c upon a, where c represents the constant term upon a represent the coefficient of x square. That is our second relationship for quadratic polynomial. Now we go for third, for the cubic polynomial. P of x is equals to ax cube plus bx square plus cx plus d, where again some condition where a does not equals to 0 and a, b, c, d belongs to R. We know the degree of cubic polynomial is 3, therefore there are 3 relationships. First is alpha plus beta plus gamma. Again we know the alpha, beta and gamma are the zeros of cubic polynomial is equals to again minus b upon a, but not a b is the coefficient of x and not a is the coefficient of x square. It depends on our cubic polynomial is equals to minus, instead of b is equals to coefficient of x square upon, instead of a is equals to coefficient of x cube. Coefficient of x cube. It is our first relationship between the zeros and the coefficient of cubic polynomials. Now second is alpha beta plus beta gamma plus gamma alpha. Read as sum of the product of zeros taken 2 at a time is equals to again c upon a, where C is equals to coefficient of x and A is the coefficient of x cube. Coefficient of x upon A is the coefficient of, from our standard form, A is the coefficient of x cube. X cube. It is the second relationship. Now last, third. Third is product of zeros. Written as alpha into beta into gamma is equals to minus d upon a, where d is the constant term and again a is the coefficient of x cube minus constant term upon a is coefficient of x cube. It is our third relationship between the zeros and the coefficients in cubic polynomials. Now next two new notes. If alpha and beta are two opposite zeros of quadratic polynomial, then b is equals to 0. b is equals to 0 means that the coefficient of x is 0. Let's see example for that. Alpha and beta are two opposite zeros. If one 0 is 2, then second 0 is minus 2. 2 and minus 2 are zeros. That's why x minus 2 and x plus 2 are the factors of our polynomial. If we multiply these two factors, we obtain polynomial. X minus 2 and x plus 2 are the factors of x square minus 4. Again, we proceed last to first. By obtaining zeros of polynomial x square minus 4, we get 2 and minus 2. X square, the coefficient of x square is 1, a is equals to 1. Here the term with variable x is missing, therefore the coefficient of x b is equals to 0 and the constant term c is equals to minus 4. See here, the quadratic polynomial contains two opposite zeros. Therefore, the coefficient of x is 0 means the b is equals to 0. Keep in mind. Now second one means last bit. If alpha and beta are two, alpha and beta are zeros of quadratic polynomial, but they are reciprocal of each other. Then reciprocal of each other means the multiplicative inverse. Reciprocal of each other, then A is equals to C. Let's see the example. If 1 0 is 2, reciprocal of 2 is a 1 upon 2. 2 and 1 upon 2 are 0, then x minus 2 and x minus 1 upon 2 are two factors. Now we multiply these two brackets with each other. X multiply x is x square, x multiply minus 1 upon 2 is minus x upon 2, minus 2 multiply x is a minus 2x, minus 2 multiply minus 1 upon 2, we get plus 1. See, by taking LCM, 2x square minus x minus 4x plus 2. 2x square minus 5x plus 2. coefficient of x square a is equals to 2 and the constant term c is equals to it is again 2. Why it is the two values are same? Because two zeros are reciprocal of each other. That's why a is equals to c. Keep in mind. There are 5 notes for our objective questions. Let's see the textbook examples. Example number 2. First of all, see the question. Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. Again, there are two questions. First is find the zeros and second is verify the relationship. First of all, we write the given polynomial. Given polynomial p of x is equals to x square plus 7x plus 10, where the coefficient a is equals to coefficient of x square a is equals to 1, coefficient of x b is equals to 7 and c is equals to 10. First of all, we need to find zeros. Therefore, let p of x is equals to 0. Therefore, p of x is x square plus 7x plus 10 is equals to 0. Again, here we are using splitting the middle term method. Coefficient of x square is 1 and the constant term is 10. 10 ones are 10. We need to find factors of 10 whose addition is 7 and whose multiplication is 10. Why it is addition? Because the first and last term are in same sign. That's why we can use here rule of addition. 5 2s are 10. 5 plus 2 is 7. 5 multiplied 2 is 10. Therefore, x square remains as it is. First part is 5x. Second part is 2x plus 10 is equals to 0. First and last term are in same sign, then the both split middle term are in same sign, sign of middle term plus plus, pair of first two term, pair of last two term. X is common from first two terms, remaining into bracket x plus 5. From next two terms plus 2 is common, into bracket remaining x plus 5 is equals to 0. Both brackets are compulsory equal. Into first bracket x plus 5, in another bracket x plus 2 is equals to 0. On comparing both the bracket with 0, we get x plus 5 is equals to 0 or x plus 2 is equals to 0. Shift plus 5 left hand side to right hand side, we get x is equals to minus 5. X is equals to minus 5. From right hand side, shift plus 2 left hand side to right hand side, we obtain x is equals to minus 2. Here minus 5 and minus 2 are the zeros of given polynomial. Therefore, minus 5 and minus 2 are the zeros of given polynomial. Now we go for next question. Verify the relationship between the zeros and the coefficients. First relationship is sum of zeros. Sum of zeros. We know sum of zeros denoted by alpha plus beta, and we complete it at minus b upon a. Here alpha is equals to minus 5 and beta is equals to minus 2. Substitute here, instead of alpha is minus 5 plus instead of beta is equals to minus 2. We know minus 5 plus minus 2 is equals to minus 7. Minus 7, nothing in denominator, then put 1. minus 7 upon 1. It is look like as a minus b upon a. Before writing b minus b upon a, see the coefficient. B 7, yes, minus 7, minus b upon a is 1. And write here minus b upon a, minus as it is. Instead of 7 is b, and instead of denominator 1 is a. But what is a and what is b? Minus b. For the quadratic polynomial, if you don't know, then remember the standard form, ax square plus bx plus c, where b is the coefficient of x, upon a is the coefficient of x square. First relationship is verified here. Now the second, product of zeros. Product of zeros is written as alpha into beta. We know where we complete it, c upon a. But c is a 10 and a is equals to 1. Now we substitute value of alpha and beta. Alpha is minus 5 and beta is minus 2. Minus 5 multiply with minus 2. Minus 5 multiply with minus 2, we get 10. Again nothing in denominator, then put 1. On comparing, numerator 10 is equals to c. Denominator 1 is equals to a. Then write here c upon a. But what is c and what is a? C represent the constant term and a represent the coefficient of x square. Constant term upon coefficient of x square. It is our second relationship about quadratic polynomial. Now next example number 3, saying from our textbook, find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and the coefficient. Here term with variable x is missing, means that b is equals to 0. So the zeros of given polynomial are opposite each other. Let's first write the given polynomial. Given polynomial p of x is equals to x square minus 3, where the value of coefficients a, the coefficient of x square, a is equals to 1, b is the coefficient of x, but here the term with variable x is missing, that's why b is equals to 0 and c is equals to minus 3. Now we go for finding the zeros of given polynomial. Let p of x is equals to 0, where p of x is equals to x square minus 3 is equals to 0. Here we apply one identity. Identity is a square minus b square is equals to a minus b in next bracket a plus b. Keep in mind this identity. X square is a perfect square. The square root of x square is x whole square minus 3 is not a perfect square number. Then write here square root of 3 whole square is equals to 0. Is related as a square minus b square. By factorizing we get x minus root 3 and x plus root 3 is equals to 0. On comparing both the bracket with 0, we get x minus root 3 is equals to 0 or x plus root 3 is equals to 0. By making x as a subject, we shift minus root 3 left hand side to right hand side is equals to plus root 3. From next to it, x is equals to minus root 3. Here root 3 and minus root 3 are the zeros of given polynomial. here root 3 and minus root 3 are zeros of given polynomial. First question is completed. Now second is verify the relationship between the zeros and the coefficient. Now we know what is our first relation. First relation is sum of zeros is equals to alpha is a root 3 and beta is a minus root 3. Alpha plus beta. Alpha is a root 3 plus beta is a minus root 3. Root 3 and minus root 3 are opposite each other, then addition is 0. Again nothing in denominator, then put 1. We know alpha plus beta is equals to minus b upon a. Therefore give minus to 0. 0 is not positive or not negative. That's why we give minus as a single type. Minus as it is. Instead of 0, we write b upon. Instead of 1, coefficient of x square, which is 1, a is equals to minus. Now what is a and what is b? Again, remember the standard form ax square plus bx plus c. Minus as it is, instead of b is equals to coefficient of x upon, instead of a is equals to coefficient of x square. First relationship is verified. Now second is product of zeros. Product of 0 is equals to alpha into beta, where alpha is a root 3 and beta is a minus root 3. Root 3 multiply with minus root 3. We multiply root 3 by minus root 3, we get minus 3. Again nothing in denominator, then it is 1. Minus 3 upon 1. Now see, minus 3 is equals to c, right? C instead of minus 3 means instead of numerator, and a instead of 1, c upon a is equals to, where c is equals to constant term upon a is equals to coefficient of x square. Coefficient of x square. Hence, the relationship between the zeros and the coefficient are verified. In next session, we will go to our next examples from our textbook.